This is lesson 3.2, Determinants and Elementary Operations. In the last lesson, we saw how to find the determinant of a matrix, and we saw that as that matrix got larger, it potentially created a lot more work for us. One of the side steps to that, though, is if we could find a row or column with a lot of zeros in it, we could use that to our advantage by then not having to worry about those entries and really make a lot fewer steps for ourselves when we found the determinant. In this lesson, we're going to look at some conditions and situations that will, in essence, do the same thing for us, kind of create less work if we can either find or create certain situations within that matrix. So the first theorem that we have here is the elementary row operations and determinants. In other words, how do elementary row operations, like we've talked about before, impact the determinant of the matrix? And so we've got two matrices here, A and B, both square matrices. And it says that if B is obtained from A by interchanging two rows or columns of A, then the determinant of B is the opposite of the determinant of A. In other words, if I take two rows and I interchange them, or two columns and I interchange them, I change the sign of the determinant. The second one, when matrix B is obtained from matrix A by adding a multiple of a row or column of A to another row or column of A, then the determinant of B is equal to the determinant of A. In other words, thinking back to, even chapter 1, we did some of those row operations where we took a multiple of one row, added it to another row. If I do that, it does not change the determinant, and I can do that for rows or columns. So think about that in terms of how might you use that to your advantage to create more zeros in a row or column, so that then when you find the determinant, it's a lot easier. And then the third one, if we basically take matrix A and multiply a row or column by a non-zero constant, then the determinant of B is that constant by times the determinant of A. So in other words, if I take a matrix and I multiply a row or a column by a constant, by a scalar, the determinant changes by that scalar as well. Okay. So in example 1, it says find the determinant of our matrix. Now we know how to do this already. We take a row, we take a column, and we go through that process of finding minors and coefficients and everything that we talked about in the last lesson. But in this case now, as I talked about, I'm going to kind of use these steps that we just talked about to my advantage to potentially create an easier matrix, or a matrix that's easier to use in finding the determinant. So for example, if I take the third row and I multiply it by 2 and add it, column. If I take the second column and I add it to the first column, so for example, if I take the third column and I add it to the first column, maybe I shouldn't be writing it by the row, that might be confusing, but I'm taking the actual column, I'm multiplying it by 2, and I'm going to add it to the first column. And then I'll store that in column 1. So what I get then is I get the matrix. So we've got 4 plus 3 is 7. 8 plus 4 is 12. And then 2, so let me write that a little clearer here for you. And then 2 plus negative 2 is 0, leaving the other columns the same. I have this matrix now that has a row of 2 zeros and a 1. So now when I find the determinant, I can focus on this third row and use that to get my determinant. And again, because I've got 2 zeros, I don't have to worry about those entries. I only have to worry about that third entry. So the determinant of matrix A then is that entry 1 times negative 1 to the 6th power, again, third row, third column, times the matrix, determinant of the matrix, 7, negative 1, 12, 1. So that's going to be 1 times 1, and then I've got 7 plus 12 is 19. So that's my determinant. Okay. Now again, thinking about what we did in the last lesson with a 3 by 3, took a lot more work when we had values other than 0 in the row or column. So in this case, using those steps that we talked about, try to get zeros into a row or a column, reducing the amount of work you have to do to find that determinant. All right, so the other thing I want to talk about is conditions that yield a 0 determinant. So in other words, how do we know if the determinant is going to be 0, or can we know if the determinant will be 0? And the answer is yes, and it says if A is a square matrix and any one condition is true, then the determinant will be 0. So again, this is just one of these things where knowing these is helpful, because if you see it, you can immediately know that the determinant is 0. You don't have to do all the work. Now, if you miss it, if you don't see it, that's fine. You do the work and you get 0 anyway, but this is just going to save you some time and effort. So here it says if an entire row or column consists of all zeros, it should really be all zeros here, then we know that you're going to have a 0 determinant. Obviously, again, think about that process we just talked about, right? The more zeros I can get into that row or column, the less work I have to do, because every time there's a 0, it's just going to be 0 plus 0 plus 0. So if they're all zeros, you're adding all zeros, you're going to have a determinant of 0. The second one says 2 rows or 2 columns are equal, same entries. And the third similarly says that 1 row or column is the multiple of another row or column. Okay, so if any of those are true, your determinant will be 0. Now, obviously, other matrices can also have determinants of 0. There's just not other ways of determining that without actually going through the work. These 3 just guarantee that you will get 0 for that determinant. So in our second example, and we're actually going to end the lesson with this, pretty short lesson here. It says find the determinant of the matrix. So again, looking at this, at least initially, I might say, well, I could pick either column 2 or row 3 because it's got that 0 in it, reduce some of my work, find the determinant. But if I take row 3 and row 1 and add them together, and I'll just store it up in row 1, what I get is a matrix of 1, -1, 1, 4, -4, 4, and you can maybe see what's happening here. Notice that these 2 rows, 1 and 2, are multiples of each other. If I multiply row 1 by 4, it's going to be the same as row 2, and based on those conditions up above, when one row or column is a multiple of another row or column, I know that my determinant is 0. So without really doing any work at all, I know that the determinant is 0. So again, it's one of those things that you can kind of watch for. Maybe even, thinking about what we did earlier, that idea of maybe trying to create more zeros or create a simpler matrix to work with. As you're doing that, you may come across one of these conditions and go, oh, I don't even have to do anymore. I know that the determinant has to be 0. Okay. That's it for this lesson. It's just really practicing, continuing to find a determinant, but using some of these ideas now to make the work simpler for you so that you don't have to go through all of the steps over and over and over again. Try to manipulate those matrices to make simpler matrices in terms of finding those determinants. All right, I will see you in the next lesson.